Hello, this is a video for 6.3b conditional probability. It's very much like the one that we did the day before, except for this one is a formula needed version. So let's take a look at the formula for conditional probability and the way that it is notated. So one thing about this formula is you need to not get tied up in exactly how this is played here. Don't think of it has to be B and A. This is the probability of the first event, and then this would be the actual condition, whatever that may be. Okay, so it will literally say what is the probability of blank given that there is a condition, or it might give you the condition first, but the last part is the condition, okay? Regardless of what is here, BA, whatever you've put in here, the formula basically says that it's going to be the probability of both of them occurring. So this would be the probability of both A and B occurring at the same time. So your condition and what you're trying to find the probability of, divided by the probability of just the condition only. So when we were doing sample spaces and we were doing conditional probability with the sample spaces, what we did is we limited our sample space. We did that in the last lesson. So what you're going to do today is you're going to use your formula to limit it for you, and you don't necessarily have to create that sample space. All right, let's get to the first example here. It says you study survival statistics of adults from the Titanic shipwreck. We've got a two-way table. It shows the joint and the marginal relative frequencies. Now remember, a relative frequency is the probability of something occurring out of the total. This is not conditional. You can tell because the grand total of everything in this chart is 1. That means that's 100% of the possibility in the total. Okay. So the way that this is written, notice how it says the probability of female, and then you've got that vertical bar right here. What you need to do is you need to write condition here. That's literally saying, what is the probability of a female given that they did not survive? So you're going to limit your sample space to just the probability that they did not survive. So your condition is going to be the denominator. And then the top is going to be the probability of both. So it's going to have to be female and did not survive. I'm going to put DNS for did not survive. So since this is a relative frequency table, this gives me the actual probabilities of everything. So what's the probability of being a female that did not survive? That would be 0.052. And we're going to divide that by the probability that they did not survive. That is our condition. Now, did not survive would be this number right here. You've got to have the total, so 0.691. So you're going to use the formula to limit that for you. So we're going to bring up our calculator. 0.052, divide that by 0.691. Round it to 3 decimal places, 0.0753. Oh, that's 4 decimal places. Oops. Let me see. Hold on just a second. Let's see. 0.075. Yeah. You can just go ahead and round that to 0.075. So that'll be about 7.5%. Okay. I don't want to lose my calculator. Here we go. All right. Let's do the other one. So we have changed conditions. So our new condition, let me change colors here, is that they actually did survive. So what's the probability of females that survived? So it's going to be the probability of both divided by the probability of our condition, which is survived. Female that survived. Let's see if we can female survived. So it'd be 0.149, and we're going to divide that by just the ones that survived. So 0.309. I'm going to do this kind of over here. Whoops. We got 0.149 divided by 0.309. Okay, 3 decimal places, 0.482. which is about 48.2%. And that's how you do it with formula. Sometimes you may not have a two-way table. Sometimes it just gives you straight statistics. It says at a school, 60% of students buy the lunch, 18% buy a dessert, and 10% buy both a lunch and dessert. So it says, what is the probability that a student, see how it says probability that a student who buys a lunch also buys dessert? Okay, so you've got to figure out what is the condition. This is the hardest part. It doesn't use the word given, so it's not obvious. What is the probability that a student who buys lunch? That seems to be what you are limited to. That is your condition. Okay, so that tells me right now, it says also buys dessert. So we're going to figure out the probability of somebody buying dessert, assuming that they bought lunch. So when I write it in this notation, I'm going to write the probability of both divided by the probability of the condition, which happens to be lunch. So what's the probability that they bought both? 10%. Divided by the probability that they bought lunch would be 0.60. So what your formula is doing is it's limiting your sample space to just that 60% there. So we're going to have to type it in. 0.1 divided by 0.6, and we get about 17%. So 0.167, 16.7%. All right, what's our new condition this time? So it's what's the probability that a student who buys dessert, here we go, also buys lunch. So the probability that they get lunch, but we're assuming that they are buying dessert. So this time we are going to do divide by the probability of dessert. We're basically switching places. Lunch on top. So that is going to be, okay, nope, I did it wrong. That should be the probability of both lunch and dessert. So it's going to be 0.10. It's just I'm not going to do lunch on the bottom. It is now dessert. So we had 18%. So 0.10 divided by 18% gives us 0.556 if I round it. So approximately 55.6%. So once again, the key is you figuring out what that condition is and then splitting it into your formula and then plugging in the numbers that they gave you. So if you understood what I did here, why don't you just pause the video, read this next example, and see if you can figure out what the condition is and figure out the final probability. And when you're ready to check your answer, go ahead and hit play. Okay, I'm just going to highlight the condition this time. So it says, what's the probability that a customer who buys a pair of pants also buys a belt? So we're going to just assume that they automatically buy a pair of pants. That is our condition. So we're going to say, what's the probability of getting a belt, assuming that they have pants? So the probability of both divided by the probability of pants. Both would be 20%, and pants will be 0.75. So about 26.267, 26.7%. This one right here, let's see, probability that a customer who buys a belt. So we're going to assume that they're buying a belt, also buys pants. So pants, assuming they bought a belt. All right, so the way this works is we're going to find the probability of both divided by the condition, which is your belt. Okay, both was the same as before, which is 0.20, but the probability of getting a belt would be 0.24. That is about 83%, 0.833, or 83.3%. All right, let's flip it over on the back here. So we've got a jogger wants to burn a certain number of calories during a workout. She's got 3 different routes that she takes, route A, B, and C. Sometimes she reaches her goal and sometimes she doesn't. Well, the point is that we're trying to figure out if one route is a little bit more successful than another. So what we're going to do is we're going to create a two-way table. So we're going to convert these tally marks into numbers. So we've got route A, B, C, and I'm just going to say check for the goal. That means they made the goal, and then no goal for that one. Okay, that would be 5, 10, 11, 11, 12. Okay, and then it would be a total of 6, 4, and 6. Now, it's important that we do the totals because it looks like she ran route A 17 times, route B 15 times, and route C 18 times. So that's going to change, you know, the probability of each. So it looks like she made her goal more often in C, but it might be because she just ran it more often. So how many times did she make the goal? She made the goal 34 times, and then this one would be 16 times here. So a grand total of 50 runs, okay? All right, so these are your condition. This is what you will be dividing by. Now I'm going to show you something that's kind of neat that happens here. We used it in our last lesson. When you find the probability of both and you divide it by the probability of that condition, whatever that condition is, now both would be reaching the goal and route A. So reaching the goal and route A would be 11. So you can say 11 out of 50, and the probability of actually being in route A. So route A, you had 17 route A's out of 50. Something neat happens on your calculator. When you do 11 divided by 50, or 11 over 50 divided by 17 divided by 50, those 50s cancel out, and you get 11 over 17. Let's convert 11 over 17. That is about 64.7%. Sorry, running out of room right here. Go away. All right, hold on, let me fix this. All right, let's try this again. So route B, I need the probability of running B and reaching the goal. That would be 11, hold up, both divided probability of B. So it'd be 11 out of 50, same as before, but then you ran B 15 out of 50 times. So the 50s are going to cancel out. You get 11 out of 15. Let's see what happens. 11 divided by 15. That is 73%. So 73.3%. So clearly route B is better than route A. Route A, she's only successful about 65% of the time. All right, let's compare that to route C. Oh, that should say C. Okay, both C and made the goal, 12 out of 50, but we ran C 18 times. So 12 divided by 18, what does that simplify to? Well, it's about 67%. All right, so which one of these routes will be the best? The 73% route. So I would suggest her running route B from now on. She's just more successful with that. Okay, so this is just a review. Now it's time for you to practice. So if you did not pause the video before, you should definitely do it now. This one right here is like the one on the front, and this one is like the running the route thing. You are going to probably need to make a two-way table just to organize your information and compare soil mix A, B, and C. Okay, so whenever you do both of these questions, unpause the video and let's see how you did. Okay, so the deal with this is you got to make sure that you know what the condition is. So the condition in this first question was who completes extra credit. So when I figure out the probability here, I need to find the probability of both getting an A and extra credit. That would be 0.18. So let me be clear. That is both getting an A and receiving extra credit. You have to divide this by the condition, and that would be the probability of getting extra credit, and the probability of extra credit is 0.27. And that is about 67%. I'm going to round it to the nearest whole number this time. And then this one, it's going to be the same, which is both, is still 18%, but this time I have to divide by just the probability of getting an A. So divide by 0.34, which is about 53% if I round it to the nearest whole number. All right, once again, I highly suggest that you pause this video, not just copy what I'm writing down in the notes. I want you to see if you can really do this problem. Okay, so I went ahead and I filled out my chart here. So this is A, this is B, this is C, and I also went ahead and figured out the total for A, B, and C, and the total that sprouted and did not sprout. So what you want to do is compare the sprout rate, but your condition would be that soil mix. So first thing you did right here is you take soil A, and that sprouted would be 11, and divide that by out of 20. So technically it's 11 out of 60 divided by 20 out of 60, but it winds up being 11 out of 20 or 55%. Did the same thing here with the sprout and B. So I had 13 out of 60 divided by a total of 24 in soil B out of 60, which changes into 54%. And then one more time, we have 10 out of 60 divided by 16 out of 60, which manages to be 62.5%. So which soil mix is more successful? We got 55, 54, and 62. Looks like we got a clear winner here. So it's definitely going to be soil mix C right here is what we suggest. And that is it for today's lesson. And you have practice problems right here. You've got a few, and just let me know if you have any questions. Go ahead and make sure that if you're an honors student, mark this question out. And y'all have fun.